Hello friends, welcome to engineering tutorial. In today's video we are going to study a new concept related to circuit theory or network theory, an important concept which is called as mesh analysis. Okay, now this concept is used to determine the currents, the unknown currents flowing in the various branches, okay, circuit branches of a network. Okay, so before we discuss mesh analysis in detail along with the mathematical analysis, first we must understand what is a mesh, the basic definition of a mesh. Okay, so here is the basic definition of a mesh. A mesh is actually a closed path. Okay, it is a closed path, a closed loop. Now that loop, that closed path, it can contain various circuit elements. It can contain voltage source, it can contain current source, it can contain resistors, inductors, capacitors, whatever. Now that closed path, the condition for that closed path to be a mesh is that it should not contain other loops or sub loops or sub paths within itself, inside it. Okay, it should be a closed path in itself and it should not contain other closed paths or closed loops within it. Okay, that is called as a mesh. So let us just see from this figure, this circuit diagram, we can identify which one is a mesh and which one is not. So here we have a circuit diagram consisting of two voltage sources V1, V2 and three resistors R1, R2 and R3. Now we have named the terminals 1, 2, 3, 4, 5, 6. Now in this circuit diagram, points, if we join the points 1, 2, 5, 6, 1, from 1 to 2, 2 to 5, 5 to 6 and 6 to 1, this is a mesh. Okay, let us say it is mesh number 1. This is a mesh. Again, if we join the points, we move from points 2 to 3, 3 to 4, 4 to 5 and again from 5 to 2, that is 2 to 3 to 4 to 5 to 2, then it is mesh number 2. Okay, it is mesh number 2. But can we call 1, 2, 3, 4, 5, 6 and again 1, that is 1, 2, 3, 4, 5, 6, 1 a mesh? Let us say mesh number 3. Can we call this entire circuit path a mesh? It is no, it is wrong. These two are meshes. Okay, mesh 1, mesh 2, but this 1, 2, 3, 4, 5, 6, 1 is not a mesh. That is wrong. Now the question is why it is not called a mesh? Because this 1, 2, 3, 4, 5, 6, it has two sub loops inside it. This 1, 2, 5, 6 and 2, 3, 4, 5, 2. And the condition for a closed path to be a mesh is that it should not contain any other closed loops or paths inside itself. Okay, that is why 1, 2, 5, 6, 1 it is a mesh, 2, 3, 4, 5, 2 it is also a mesh, but 1, 2, 3, 4, 5, 6, 1 that is not a mesh. Okay, so always remember it. Okay, so this is about the basic definition of a mesh. Now we will see how we use this mesh analysis to determine the unknown branch currents. So now we will discuss how we use the mesh analysis to find out the branch currents in a circuit. First we will discuss the basic concept, then we will further understand this concept by applying it to solve numerical problems and find the unknown currents. So we have used the same circuit which we discussed earlier, which contains two voltage sources V1, V2 and three resistors R1, R2 and R3. Here this the current in the left mesh, the mesh current is I1 and the current in the right mesh is I2. Now please pay attention to the polarities that are placed on the resistors R1, R2 and R3. We know that current always flows from positive to negative terminal in a resistor. I have said it many times in my previous video also related to basic concepts related to circuits. Because resistors, they are power absorbing elements, that is why current will always flow from positive to negative internally through a resistor. Here also I2 is flowing from positive to negative internally through R3. The important thing here is R2. Here for I1, when we consider mesh left, the left side mesh, the mesh 1, well, consider that with respect to I1, because I1 is the dominating current, with respect to I1, current will flow from positive to negative through R2 internally. But when we consider the right side mesh, the mesh number 2, with respect to I2, because I2 is the dominating current here, the current will flow from positive to negative in this direction, upward. In this case, the mesh current I1 is flowing downward from positive to negative internally. In case of I2, the mesh current is flowing positive to negative upward through R2 internally. So that is why there are two polarities that are placed. It has nothing to do with the real convention. Just for the right purpose of writing the KVL equations, we are placing polarities, okay, with respect to the dominating current. Okay, so now let us just write the KVL equations for mesh 1, okay, this side, the left side mesh 1, and we will use the second sign dominating method of applying KVL. I have posted two videos related to KVL application in my channel. You can check those videos where I have discussed in detail how to apply KVL in a circuit. So I am using the second sign dominating method. So the KVL equation for mesh 1 is V1 minus I1 R1 minus, here the current flowing through R2 with I1 being the dominating current will be I1 minus I2, because they are flowing in opposite direction through R2. Current I1 is flowing from positive to negative downwards, current I1 is flowing downwards, I2 is flowing upwards. As I1 is the dominating current, it will be I1 minus I2. If I2 would have been flowing in the opposite direction, okay, it is flowing in clockwise direction. If it would have been flowing in anti-clockwise direction, it would have been I1 plus I2. But here, as I1 is also flowing in clockwise direction and I2 is also flowing in clockwise direction, they are actually opposing each other through R2. It is flowing from upward to downward through R2 I1, and I2 is flowing downward to upward through R2. That is why I1 minus I2 R2 is equal to 0. The KVL equation is this, that is the summation of all the voltage of dependent and independent sources along with the voltage drops across the various circuit elements is 0. So we can further simplify it as I1 R1 minus I1 R2 plus I2 R2, okay, minus I1 R1 minus I1 R2 plus I2 R2 is equal to minus V1. So if we just do negation, we perform negation, it will become, the minus will become plus and the plus will become minus. That is I1 R1 plus I1 R2 minus I2 R2 is equal to V1. Now if we take I1 common, okay, it will be R1 plus R2 into I1 minus R2 I2 is equal to V1. Okay, so this is the mesh equation for mesh number 1, the KVL equation for mesh number 1. Always try to bring the equation in terms of I1, I2 and V1. Okay, it will be very helpful. Always try to bring it terms of I1, I2 and V1. V1 should be, because it is a constant parameter, it will be DC voltage or whatever it will be a constant value. Always bring it in this side and keep I1 and I2 as they are the variable elements. Always bring the equation in this form, it will be easier for you. Similarly, we will write the KVL equation for mesh 2. Okay, so now we'll write the KVL equation for mesh number 2. Okay, so here I2 will be the dominating current. I2 will be the dominating current, so it will be minus I2 minus I1. See, in the previous case we used I1 minus I2 because I1 was the dominating current, because we are considering mesh 1. But here, as we are considering mesh 2, so the mesh current I2 will be dominating. So that's why minus I2 minus I1 R2 minus I2 R3 minus V2 is equal to 0. So again it will be I1 R2 minus I2 R2 minus I2 R3 is equal to V2. We have just opened the bracket. Now we have to bring it in terms of I1 and I2. So it is R2 I1, okay, minus R2 plus R3 I2 is equal to V2. Okay, we have brought it in terms of I1 and I2, and this is the constant value. So this is the equation number 2. Okay, this is equation number 1 and this is equation number 2. Okay, so now we have to bring it in terms of a matrix form. Okay, matrix form. So we'll bring it in terms of matrix form. So let us see how we can do that. So we have these two mesh equations which we just obtained by applying KVL in the two loops or the two mesh 1 and mesh 2. Now we have to bring it in terms of matrix form. That is, we will write R1 plus R2 and minus R2. Then we have R2 and minus of R2 plus R3. The two variables which are involved here are the two mesh currents, okay, I1 and I2, and the two constant values which are generally given in the circuit are the two unknown the two voltage sources, not unknown, they are known. The DC voltage sources we have taken in this case, that is V1 and V2 as per this two equations. So this is the matrix form of arranging the KVL equations or the mesh equations. Now in order to find the values of I1 and I2, you can use either Kramer's rule, okay, you can either use Kramer's rule Kramer's rule comes in handy when there are many mesh given. Suppose there are 3 mesh, then there will be 3 equations involving I1, I2 and I3, 3 variables. So in that case it will be very difficult to solve it by variable substitution method. It will be very lengthy and there is more chance of committing a mistake. So in that case you can use Kramer's rule. But if there are only 2 mesh, that is 2 equations and 2 variables I1 and I2, you can solve it by simultaneous equation variable substitution method. Okay, you can use the variable substitution method to solve those circuits. Here there are only 2 mesh, that's why we can use this method. Okay, but when there are more than 2 mesh, there are 3 mesh, then you can use Kramer's rule. Variable substitution means that you establish a relationship between I1 and I2 from first equation, then you substitute either the value of I1 in terms of I2 or I2 in terms of I1 in the second equation, and you find out that particular variable value, be it I1 or I2. Then using that value and putting it again here in mesh 1, you find out the value of the other variable. So we will discuss that in detail in the numerical problem solving part. We will solve many problems related to mesh analysis. There we will discuss in detail how to use variable substitution method, how to use Kramer's rule. Okay, so we will discuss that. So this is all about the mesh analysis. You can do that using 3 mesh also, but here to give you a general idea, I decided to go with a 2 mesh circuit. We wrote down the mesh equations using KVL, Kirchhoff's voltage law, and then we arranged it in this way. Okay, in terms of the mesh currents I1 and I2, the coefficients of I1 and I2, and then on the RHS, the right hand side, we have the 2 voltage sources. Okay, so now next we will discuss various problems, numerical problems related to mesh analysis. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.